Welcome, everyone. This is Bobby Harris, the Executive Director of the Utility Broadband Alliance. It's my pleasure to welcome you to today's webinar. As you're getting logged in, let me just remind you that we will take questions for our panelists towards the end, and you'll be able to use the questions box on your toolbar from GoToWebinar. And just remember that how you type them is how I will read them. We don't say who types them, but we do read them exactly as you type them. And as many of you know, me not being an engineer, I will read them exact, especially with a highly technical topic like this. So, and then our panelists will answer them for you. So we appreciate everyone being on with us today. We know you have a lot taking your time away, and I don't want to take up any more time. I just wanted to welcome you, and I wanted to thank our panelists here today from Itron and Keegan. Not only is this a highly technical topic, but it's highly important for utilities. And this is one that we will continue the conversation in Charlotte at the UBBA Summit and PlugFest in November, and we'll talk more about that later. But this topic gets brought up a lot in our working groups and when we're talking with utilities. So I'm going to turn it straight over to Jan Forslow from Itron to let him introduce the topic and our panelists, and we'll come back on for questions at the end. Jan, take it away, sir.
Yeah, thank you, Bobby, and thanks everyone for joining this webinar. I hope it will be fruitful for you. We have called this topic future-proofing utility connectivity with SGP.32. That is like with eSIM and multi-profile SIM cards and so on. And it is a topic that definitely both Keegan and Itron has been working on, both in public sense and now also more for the private network side for a while. But these standards have been coming along, so it's really fun to see that we're getting to more standardized approaches. I have with me Oleg Pashkovich, a colleague of mine who is a senior product marketing manager and actually have lived in this environment longer than I have. So I will rely on him on a number of questions related to the market when it comes to modems and eSIMs and so on. And then we have Jerry John, who has helped us a lot, and we have worked very closely for several years with him and Keegan on how to make optimal setups, and they have been very helpful in things that where we have said, okay, maybe this need to be modified a little bit, and be able to drive that. So this is the outline of topics that we're going to go through, and I'm going to take you through some of the basics, but very important portions in the beginning, and then we'll come more to how to manage, for example, Oleg's aspects about working with carriers and how to get profiles and contracting and so on, as well as it looks a little bit different depending on what kind of AMI 2.0 network architectures have, and what in terms of what you would do in when it comes to profile management. And I'll talk about sort of vanilla default architectures versus a little bit more hard and robust architectures. Oleg will take on and talk a little bit about orchestration and connectivity management platforms. And then we have Jerry will take you through a bit like how do we actually work when it comes to if you have a private network, how is the onboarding, how is profile donation, and so on. And I'll end up with some of our lessons learned so far and recommendations, and we'll open up for questions and answers. So very first then, related to standards. So we say SGP.32, which is it's a sort of one standard, and SGP stands for, there's a lot of acronyms in this world, so I'll when I see them I'll explain. SIM group profile, it's a part of the standard, and these standards, as you see, are coming from GSMA, so it's not like 3GPP standards, so GSM association, which is a little bit more driven by carriers and SIM card vendors and so on, than 3GPP, which is more infrastructure vendors and that ecosystem. So SGP.32 is the one that is closest to be adopted and finished. The standard is complete, and you see a lot of vendors starting and infrastructure carriers and so on saying, okay, well, we're getting ready to adopt this standard for IoT then, I would say beginning next year. It is sort of follow on from something that has been in the consumer market a long time, the SGP.22, and has been very successful for consumer handsets and so on, but now adapted for IoT. It's really like a framework for online management of profiles on your SIM cards and eSIMs. It's actually not saying particularly this is a specific protocol that you're going to use, and that's a little bit important. You'll see that later on, but it's more of the framework for it. And then there is another standard that is still ongoing. Probably it's 1-2 years away from being fully finished, but there's a pre-versions of SGP.32 already, and it's actually a quite important portion. Sometimes I feel, as I have been going into this, that it's equal or more important than SGP.32, because as you see, the title, we call it in-factory profile provisioning, is very tight to how can you manage and do this in manufacturing, but actually very useful, this kind of offline profile package delivery for also field tools if you're troubleshooting in the field and so on. So it has multiple usage, and this goes really hand in hand for a complete solution. So that's to remind you, like, these are the two standards that we're watching and working actively on. One is a little bit more mature, SGP.32. So we've seen it first, the specs being done and certifications going on, and more you will see it in live environments next year. SGP.42 is probably 1-2 years later in its cycle, but there are pre-versions already available. So I'll go to the next topic, which is more equally important here, and that's like what use cases we see for eSIM standards. And because of the names and so on, you often hear and talk very much about remote SIM provisioning, which is here on the right side. It's very good, but actually probably not going to be the most used use case, but it is like you have it there if you need to, if you make new contracts with the carriers or other things, or future-proofing your secure remote profile updates. So you could actually download them over the air and make any changes. But don't expect that you do that too much. And depending on type of product you have, it could be that, for example, battery-powered products, if there are some of those, then you will be a bit concerned doing these changes too often, as it drains battery life as well. So quite interesting is the other use cases here, and I'll start from the left side. We call it customer SKU reduction. You could probably have other names, but if you think about it, at least we see a lot field deployments where the field installer has to go out with multiple, in our case, meters or devices, because even if we have done a lot of good network planning and we are getting all the sort of signal strengths and so on for different locations from carriers or from private deployments, it's still this kind of worry, maybe it's actually not going to connect well when you actually get there on site. Previously, for a long time, as long as I've been working with this, often people have had like a second meter or similar with another carrier profile, carrier SIM card, and then carrying multiple, and have to, if the primary doesn't work, they have to go and exchange and put in the secondary meter with the secondary carrier. Now, if you have eSIM and you could load multiple profiles, it's a lot going in and how you work out your contracts, and Oleg will cover that a little bit. But if you can do that, so you can go out with multiple profiles to start, then you can actually have this automated, these checks. Does the primary actually work reliably? Shall I go into the secondary and use that one instead in the installation? And that will take you away a lot of headache during installation time. The second one is more for resilience, like in case something happens with the network in real time, and that is to have a fallback, a switching fallback mechanism in the eSIM or in the device, and drive that so that you go to another network in the meantime. And I would say, like, because I often get questions like, how fast does it go? And this is not meant to be, it is not targeted to be extremely fast and swapping back and forth between networks and so on. And as we have learned the hard way, in some cases, when it comes to network switching, there's much more to be done than just changing the profile. It's even to the level that sometimes firmware has to be changed as well in order to connect to the other network, because in sometimes networks have their specialized firmware and so on. So it's a little bit more. So what we have seen in real deployment so far, it's more you talk about if you see an inactivity or like not reaching the network for 1 hour, then you would start switching. But it's not, even if we do it in demos, like in minute level, that's not generally what is set in the field. So it is really a fallback mechanism. And then the third one here is for the field personnel. If you are troubleshooting and so on, you have field tools, and these field tools can have the capability to inject new profiles into the devices more locally. So that's a good fourth use case. So then I'll go to the next slide. And this we wanted to put in a little bit about different form factors. So the removable SIM is the ones that we've had for a long time in the industry. It's been the 2FF, 3FF, and 4FF, or mini, micro, and nano type of plastic SIM cards. And it's been flexible and so on, but they do increase BOM costs and BOM components, and also prone to physical failure and tempering. So as same as for the consumer side, the IoT side is moving towards the right here. And I would say the market is going, and as its first to stop here, being more in the soldered in eSIMs. And there you have a machine-to-machine form factor or ball grid array form factors but they really solder down on the board so that it gets better, high reliability and tamper resistance and so on that one. So I think that's what we're seeing right now. And then I will say when we are looking for sort of the next revisions coming in 2-3 years or similar when it comes to modems and so on, then it's going towards that it's integrated the SIM with the modem, so there's no extra hardware at all, and actually the profiles gets then loaded to the eSIM in the modem itself. So this is a trend that I don't think anyone in our sector of the industry will stop. It is ongoing, and it's sort of getting proven by the consumer side already. And then next topic is like when is profiles potentially inserted into the SIM card and why and so on. So what we have identified, and all of these are pretty relevant, but some are complementary of them, and maybe you don't do all of them. But maybe the simplest one is to actually work with your SIM card vendor, like for example, working here with Keegan, and they can help and preload profile before they actually ship the SIM cards to an OEM device vendor like Itron. That has a little bit simplicity, and we utilize that a bit in the beginning here for us with Jerry and Keegan, because it streamlines, maybe don't touch and implement all the changes that you would have in different manufacturing environments. But it has its sort of negatives, that you need to know exactly what you're going to do very early on in the process. And we have we have a lot of requests on the other side, is to actually adjust products later in the game, like build to inventory and so on, so that it gets more flexibility. And that's where sort of in-factory provisioning is a fairly big one, so that you actually could decide and you have a single SKU all the far into the manufacturing, and then you specialize it with profiles later on. And that's, so you see the first case where SGP.32 is very handy, then that you could get the profile files and load those in the manufacturing, as both of these like a very secure environments when you're doing the manufacturing. And then we have the field provisioning, which also is the device itself have problems connecting and so on, so you really need to have the SGP.32 style of injector profile through the side loading in that case. And then we have the remote SIM provisioning, where we could be over there online from a remote server, and that's more handy with SGP.32 there as the base. So those are the different times sort of you can see you would utilize eSIM profile insertion.
And going back to the previous slide, right, Jan?
Yeah.
The preloaded profile, I mean, essentially, or the slide before, every single time essentially that you have multiple profiles or single profile or two profiles becomes a management of SKU, right? And with that, you have to manage lead times, you have to manage the logistics of storing it, the various, I guess, processes involved with pulling them off of inventory and building with it. And likely with Itron and with Keegan, you have minimal order quantities associated with that, right? And so what, the middle flows in factoring and field allow for Itron to do is to build a maybe static product that is one SKU that for most of the world you can use, but then when, let's say there's a deployment that requires a specific private LTE carrier from a utility X, Y, or Z, then you can augment them as needed as you ship them out.
Yeah, that's a great addition. Thanks, Jerry. I'll leave it over to Oleg a little bit here, and he's going to talk about different setups where we've seen and thinking about how you work to create those with contracts and so on.
Right. Thanks, Jan. So indeed, we have commercial deployments, and we have some pilots, commercial pilots, where we explore all these different flavors of multi-carrier SIM card and multi-carrier connectivity. As you can see here, there's kind of two main options, more or less. So where the easiest one will be to use the public carriers and multi-public carriers, and this is primarily for the redundant and reliable connectivity. So a SIM card will have preloaded profiles, and then depending on the environment, depending on the connectivity conditions, so one or the other profile can be used. And as you can imagine, with two major carriers, at least in the US, we can achieve like nearly 100% coverage, where it's nearly 100%, because like utilities, they have their areas where there's still gaps, and there's still, we need to improvise there, either with satellite or some extension of coverage, but mainly these two carriers, they can cover quite a significant portion of the territory. And this introduces the lowest entry costs, so there's almost no upfront costs. And so the challenge here in this public multi-carrier network connectivity is rather to work with the carriers and to align the requirements, but to align the commitment for Verizon and AT&T, for instance, to be on the same SIM card, to work together, which is the standard, SGP.32 standard, or EUICC, provides a secure way to separate the carriers from the SIM card logically and securely. So these profiles, they are entirely independent. Nevertheless, the content on the SIM card needs to be aligned with the carriers. So this can be done, and we have deployed this solution commercially, or similar solution to that. So the second version of it, the second flavor, is this where people deploying their private networks, and for having a backup connectivity on private network, one of the carriers is typically used. So this is either for the backup connectivity, or for instance, if the private network is being deployed, but there's some areas where it is not deployed yet, so where the solution can start on a public carrier, and then as these sites are built out, it can switch to private network, either by provisioning the profile over the air, or this profiles are typically known, and they can be preloaded, and so the moment the device, the SIM card, sees the private network, it will switch over to the private network. So yeah, and as I said, both of those cases focus mostly on reliability and redundancy of connection, and this is where this multi-carrier technology introduces a great potential for this approach. Next slide, Jan. Yeah, here I would like to highlight two different architectures, and in a second I will tell you like why is it important to understand, or like what's the specifics about those. So as you know, they can be like typical deployment. Here you see on the left side, this is where neighborhood area network is connected through let's say through a mesh or PLC connectivity to the aggregators like access points, which are connected to different carriers, so to one or multiple carriers. So in that case, so the data from individual endpoints, from individual meters, is being aggregated on the access points, and the connectivity, the cellular connectivity, is provided through the access points. So this brings this advantage that through the aggregation of the data, the costs of the connectivity can be reduced significantly. And in that case, so they can be like one or two backup carriers on this access points, and the costs are very manageable or almost negligible, projected on every individual device. So now looking at the second case on the direct cellular connectivity, even so exactly the same technology can be applied there, but the problem here we have that if we put two carriers, so like redundant, even for PLTE, we put a redundant backup carrier onto the endpoints, it creates some significant costs. Maybe not significant, let's say on a monthly basis on a device, but when we look at a typical deployment of 2, 3, 5 million devices, then on annual basis, this is like a multi-million insurance policy. And this needs to be considered. And there's some smart strategy how to do this, but in that case, so maybe remote SIM provisioning is a viable feature where we say like, if the area is about to change, then maybe we can provision a certain like carrier that has connectivity in this area in the field, or let's say enable this carrier like only as needed. So different strategies need to be considered, but basically the main difference on these two architectures is to consider the costs of redundant connectivity. So passing back to you, Jan.
Okay, great. Thanks so much. So I'll go in a little bit on system architectures for SGP.32 and so on here, and you have a little bit of explanation of abbreviations here in the lower right corners. You see something, but I'll walk it through. So if we start with the SIM card first, so the EUICC, that one has actually structure and which is different security domains here, and you have one that is the root. That's where you have something called an IoT profile assistant, and that is like the one within the eSIM that manage like the additional profile additions and removal and so on. In the application area in ISD, there you could have, and at least in our case, there's a carrier management applet, and that's more the logic to make switching. Like if you do the failovers and so on, all the logic for that you could place in the CMA. And you know, the good thing is placing it in sort of this application area is that it's not going to be tied as much to certified code that goes certification with GSMA and so on. So you actually could have tailoring of the CMA a bit for the device deployments. And then you have the profiles themselves. That could be one or many profiles in here, but as Oleg mentioning, there is certain costs with every profile, even if they are fallback profiles and so on later, so one have to consider that. So that's what you have the SIM card, and then you have a server, a remote server called the eSIM IoT Manager, and I call it like that's the source of truth when it comes to what profiles are running on which devices and are active and so on. So that one should always get updated in the operation. And then you have the top ones here, which is SMGP Plus, that subscription manager data preparation. So the blue ones I draw here, that would be in the private side, being, for example, worked here with Itron and Keegan, you would have SMGP Plus with Keegan. But then for any other networks that you want to also have support for, then those SMGP Plus, they live with each carrier itself. And most often the carriers have their individual connectivity management platforms from which, so you know, you have the different, like for example Verizon ThingSpace and so on. Those are CMPs that allows you to manage the life cycle and so on of each individual eSIM profile from there. So the operations are, if I look at the big ones, so often like the vanilla architecture is that you have the direct profile downloads that are actually coming from this SMGP Plus. So it could come from Verizon's or AT&T's SMGP Plus direct to the IoT device and eSIM communication there. And then you have profile management operations back and forth between the eSIM and the EIM. I click one more time here, and why I call it vanilla is like, so these are some of the weak points we have seen with this one. So if you look at this one, every device is now communicating to the SMGP Plus, and SMGP Plus is communicating over the internet. So it becomes like a very wide opening for in terms of network if you do this approach for direct profile download. Also, the operations that are defined today is more run to completion. So if you have a low power wide area network that maybe in real life as can be slower, faster, and so on, and they can, you know, easily time out, we have seen, and so on when it comes to these operations. So that's another weak point today if you use the vanilla architecture. And you know, vanilla architecture typically have just picked up from consumer side, like HTTPS TCP as a protocol, also for the profile downloads, and that's an additional protocol importance so on to open, but also TCP generally is not so efficient on a low power wide area networks like Cat-M1 and so on. So profile switching, I marked it often in the vanilla architecture. It's here associated with the carrier management applet. It does though switch, that switch to profile, but there's other network settings that also need to be set that only the device knows about, like it's everything from APNs. It could, as I mentioned, be firewalls and firmware updates or settings and so on that need to be updated, and IP addresses and other things. So there's more to it. So purely relying on the eSIM to make the profile switching standalone is a weak point. And then depends on how many you integrate with and so on, but at some point this becomes fairly hard to manage unless you have your own carrier manage and SIM profile orchestration. So that is sort of lacking in this vanilla architecture. So
Yeah, but,
yeah.
but what is nice about this architecture, the vanilla architecture from 32, is that the integrations to access profiles from our SMTP Plus, like you said, on our internet. So we do not need unilateral integrations to be able to access those profiles. They are hosted on the internet, so really the only connection that's needed is an internet connection. But then we're also bringing over the remote aspects that were prevalent in the M2M spec, being brokered by the EIM, which allows for remote management and really, like you said, using the EOSC information set associated with that EOSC within the EIM to then serve as the source of truth of what's been downloaded and the various states of those profiles.
Yeah. So relying actually on being compliant still to the standards, as I said, this is standards that are protocol independent and so on, is this little bit more hardened system architecture, which depending really a little bit about device types and so on, you might go more flavor there. So more when you get to the mass market products, lower end products and so on, you probably tend to go more to here. If you're more on that first architecture, Oleg said, where you use access points and so on, then you can more easily stay with the vanilla architecture because it's fewer items. But here you can see some of the differences. First of all, like an introduction of a connectivity management platform that actually coordinates across carriers and the private network side. So you have the one both user interface, but also APIs to work towards to manage the life cycle of profiles and activations with the carriers and associated to the contracts that you have. It also an interesting aspect. Actually, this one became, oh, sorry, that one became a little bit wrong. This should come from here. So the interesting portion with this one, there's both in SGP.32, there is what we saw before was a direct mode, but there is an indirect mode so that you can actually start a session but have the EIM being broker for the communications to other devices. And then based upon how you deploy EIMs and AMI headends, you can get that to be secure connections to all the devices and have a much more limited VPN or interface here up in the higher level. The alternative actually, which we have also looked on, is to use more of an SGP.32 bound profile package. So that is it's a profile, but it's also added with security credentials and so on, so that it can securely download it. And then you have more of a file that you're downloading towards the device rather than having this online procedure. And in those cases, you can even do more when it comes to how you get it over reliably. So similar to like when you do firmware downloads and so on, you could start to divide this up in individual blocks and don't have sort of a preemptive procedure. So even if a session ends abruptly, you can just continue so that you don't overuse networks like that. And you can go over to use protocols that you might have for the devices already, like DLMS COSAM over UDP, which is a little bit more efficient protocol for scale. And then finally, when it comes to profile switching and so on and coordination, you can optionally rely on some of the functionality in the CMA here in the SIM card, but you can have additional then functionality or take most of the functionality out and run in the device itself here exemplified by the IT profile assistant in the device, which is also part of the standard. And then you can actually coordinate APN switching, firmware changes if it's needed to when you do a switch to another network. So these are sort of what we have seen some of the examples of a little bit more hardening the architecture for eSIM. So I'll go and leave it to Oleg here to talk a little bit more about the connectivity management platform.
Great, thanks, Jan. So yes, a few words here on connectivity management platform. just because it is sort of being overseen, at least during the initial phase. So during the initial phase, where a few devices, maybe a few SIM cards are managed, it's actually not a big deal because every carrier provides a CMP and all connectivity and everything can be managed through the carrier CMP. However, if things get scaled and we out of a sudden need to manage like millions of SIM cards, millions of connectivities with all different configurations, like on different projects, so this becomes a challenge. And so on our side, so we have implemented connectivity management platform that is integrated with the carriers on the first stage, but also it is integrated with our manufacturing center to provision devices, to provision SIMs. And at the same time, it is also integrated with eIM to manage the connectivity or to retrieve the information about what is going on the SIM card. Because if you look at the architecture, let's say SIM card or device, and then connectivity itself, connectivity management, they don't have a connection. So the connectivity management platform, it is looking northbound. It is only looking at the configuration of the connectivity on the carrier side, where eIM is looking on the southbound, is what is going on the device on the SIM card. So now there's no link between northbound and southbound. They're kind of like, per definition, they're independent. So, and this is important to consider, that there needs to be a link for the let's say life cycle management of the connectivity to be aligned with what is actually going on the SIM card. Or a good example would be like if you have a device in the field and you have like local connectivity management or even eIM connectivity management through eIM, and let's say you disable or delete this profile from the SIM card. What happens to your data plan? What happens to your like configuration on the carrier side? Well, and to say here, nothing happens there until you take an action. But so like you still will be paying for this connectivity, even so this profile even has been deleted. So there needs to be a synchronization between what is going on the device and what is on the data plan on the contract with the carrier. So, and all this is handled through the connectivity management platform. And so, as you can see, some bullet points here, like eSIM device connectivity provisioning. This is what we do through connectivity management platform. eSIM visibility and control, so we can see which profiles are installed on the SIM card, which profiles enable, disable, and we can trigger these actions through there. Life cycle management, this is what I mentioned before. If something happens on the SIM card, profile is deleted or needs to be replaced, and so all this is triggered and managed through CMP. Then we have one device, one SIM card, multiple carriers. So we cannot approach this like from multiple like CMPs, like managing these individual devices from different connectivity management platforms from the carriers. This will be quite an overhead on operational efforts. So that's why the CMP in our case is unified multi-carrier management platform. Remote SIM provisioning, this is also triggered and monitored through CMP. Data plan optimization, as mentioned, so like different data plans, different devices, different projects is there, and connectivity billing, auditing and validation, and also revenue assurance and costs if the connectivity is being resold or like offered externally. So all this is managed through connectivity management platform, and this is why I would like to emphasize the importance of it, and because it is oftentimes being overseen, overlooked in the beginning. And so here this is what we have identified throughout our testings and deployments, that this is an essential component of a multi-carrier solution.
Thanks, Oleg. So now we'll hand it over to Jerry a bit to talk through a little bit both how this integrates with Keegan and Itron, as well as like how is then onboarding go? How do you do that in terms of if you have a private network coming up?
Yep, thanks, Sean. So you can see here what Keegan has done with the hub of Itron is really take a technology stack that was initially developed for service providers. If we look at what we've done for SGP.32 and even 22 solutions and USC solutions for service providers, it's been a stack that really has been used only for the serving of profiles and those types of solutions, right? And so what you have is MVNOs who are building the CMP aggregation. They're working out the reseller rate plans. They're leveraging our servers to then push those profiles down to the USC, and then that becomes a service they're selling. What we've realized is that from Keegan's perspective, we know what we know, which is the profiles. What we know is the USCs. We know how to onboard private networks. But then when we work into the IoT realm, this amalgamation of carriers, we like to leave that to the end customers. All the carrier rates, the carrier plans, how to know when to activate, what to activate, the rate plans, that's completely outside the jurisdiction of what we do, as well as knowing that for someone like Itron, they have very thorough and robust device management and device client solutions serving their own protocols, right? So what we did was we took the Keegan solutions, we looked just like what Oleg said at the northbound interfaces, the southbound interfaces, and we identified how would we build solutions to link to what Itron is trying to accomplish. And for that, we were able to provide APIs via our what we call Keegan Pulse, which are the Keegan APIs, northbound to allow the CMP to manage the profile states, to force the downloads, to use our servers as essentially a source of truth of what's on those USCCs. But then on the southbound, we allow our servers to integrate directly to the AMI headend and firmware of the Itron devices to then allow for instance, delivery of profiles and profile states over the Itron, what do we call the secure and preemptive DLMS/UDP protocol, right? And of course, at the bottom is our USC that contains essentially the extension of both the RSP servers as well as holding the credentials that are extension of the utility and MNO networks. And that's a good point to segue into the next slide, Jan, if that's okay. Because what the SIM is serving, what the profiles are serving are essentially the field anchor or extension of that carrier's network, right? And so in order to do that, the SIMs themselves contain the very sensitive MNO keys and also the file structure and applets of the MNO utilities to enable these devices to connect to the cellular network. And so for a utility or MNO or MVNO to participate in the infrastructure that Itron has built along our RSP and EOC solutions, we look to essentially have profiles donated to us or generate the profiles themselves. But what's common between all those is that all those profiles are generated and developed within our very secure Keegan data centers, which are GSMA SAS accredited. And so within those GSMA SAS accredited data centers, we're housing the network keys to be able to generate the MNO profiles. We can then use the generation of that profile to enable the loading of those profiles in manufacturing. So for instance, in a preloaded SIM, regardless of whether it's a IE-OCC, which is integrated, a soldered, or plastic. But then we also are able to generate the profiles to be hosted on RSP servers. And those can be downloaded via the SMDP Plus or in the in-factory solution via our SMDPF to then be delivered to the EOC, whether in an in-factory or in-field solution, as Jan has alluded to earlier. Next slide. And so the onboarding that network, the onboarding the utility network then becomes the most important part of being able to build these types of solutions and to serve all the various use cases, right? And so what Keegan has done is we understand that the utility private LTE networks are likely quite new to this. This is something that the MNOs and MVNOs may have taken on earlier on, but it is quite new for some of these utility partners. So we do come to them in a consultative approach. We work with them to define essentially what they want the SIM to do. That includes identifying, for instance, how we want the devices and SIMs to prefer networks, how they get onto networks when they first power on. We look at the requirements of the types of devices they're trying to serve, whether they're trying to meet a low power sector. We look at, for instance, maybe some configurations we can set in the profile itself to deal with the IoT configurations, the 5G settings, and the IMS requirements. We're talking about like VoLTE and SMS over IP. And then we also work with them to understand ICID, IMSI, and numbering schemes, and how do we build a profile and configure these profiles to enable connectivity to the private IT infrastructure, and that looks at their DNS, their IP, and potential APNs that they'll use. The next step we do with them is we support the very secure key ceremonies that are needed to essentially extend the SIM as a trusted anchor back to their network, right? And for that, a lot of it is the education of what these keys actually do. So we consult with them on the processes for key handling, consult with them to align them with really our processes as well that we built into the tooling for these sensitive key exchanges, so that not one single entity is able to have access to these keys. And we also work with the core network vendors that they choose to also ensure end-to-end secure processes for both loading those keys into the infrastructure, but also how do we pass the SIM specific data later on once our products are being produced. And finally, just like what Jan has mentioned, we work with them to show them how the EOCs are configured, right? So whether it's an EOC that's being served by them or an EOC that's served by someone like Itron, we showed to them how the SGP.32 architecture capabilities work. We show them essentially how, by nature, a multi-profile solution is needed, especially when we're looking at resiliency applications. We also help them to define how to essentially define the configurations needed to ensure, preferential treatment of their home profile, but also allowing for a failover profile as needed in the field. Next slide. And of course, I think what we discussed previously was the intersection between the northbound and southbound interfaces, right? And that's where Keegan Pulse comes into play. So Keegan Pulse is our abstraction layer from both our data services as well as our RSP solutions. And so as Oleg and Jan mentioned, we enable, for instance, APIs to have a delegated package that's dedicated for EOCC. We allow, for instance, Itron to fetch that and deliver that via their own device management means. That enables, for instance, SGP.32 profile state management commands to be sent via their own protocol. Northbound, we allow, for instance, the CMPs to access the EIM to really look at the EI's inventory to understand, for instance, the states and support the downloading and enabling of profiles remotely. But also we use Pulse as a gateway to be able to request those offline SGP.42 in factory profile blobs, as I call them, binary large objects, to allow for fetching of profiles to be installed. And also we will use Pulse as a gateway for some customers as well to enable, for instance, eSIM binary large object blob deliveries as well, to enable the eSIM loading of packages onto secure connectivity modules that support the integrated SIM.
Great, Jerry. So just to, I was looking through like what's part of the lessons learned here and can be recommendations as you're looking at this also going forward. So I put 6 items here. There's probably more, but first then, GSMA is like not 3GPP. I'm very accustomed to 3GPP standard and so on. So GSMA Association does not really prescribe protocols, and the ones that come up as default then from consumer world with is really a little bit more run to completion, so I'm not fully adapted to low power wide area technologies like that we apply for the lower end devices like metering. So you really can work within the standard to select the optimal protocol and procedures to be able to drive scale in this area for IoT. Second one is like RSB is the one, remote SIM provisioning is the use case that gets most focus, but actually probably the more used will be the other ones I mentioned, like the customer SKU reductions. You can have one SKU out when you go and install, the active carrier resiliency in case of failover, and in-field provisioning when it comes to troubleshooting. So those are really key use cases as well. And then we are going towards away from removable SIMs, just as the consumer market have done, towards soldered down eSIMs and eventually iSIMs, integrated SIMs with the modem. And that's for robustness, security, and cost efficiency. I didn't mention it, but some of our colleagues, Alex and my colleagues, are also spending a lot of time to actually validate and certify every component that goes into our products, that it actually follows all material conditions and so on. So even the SIM card and so on has to go through that in order to actually fit into the and be used for deployments that should last, 15, 20 years. eSIM switching, that's where you have to think about like changing the profile is not good enough, not everything you need to do when you're switching from one network to the other. So there are other aspects, like the simplest ones are APN, but as I mentioned before, there are firmware settings and other things that could be triggered in order to go to another network. So it's a little bit more complex, and device vendor and functionality needs to be aware in order to actually make this complete and more seamless. And then this ties a little bit to what Oleg talks about, like, if there's a private cellular deployment, then mostly we are looking for public carriers to help us with fill-in where we don't have coverage, or fallbacks for redundancy. That's not maybe so lucrative. So it is what we're seeing here. It's better to be able to package that together with large other engagements with carriers, so that you actually can get successful contracting for both this kind of use case, as well as bundle it together with the other use cases where carriers maybe are more prime in those deployments, so that you get good contracting for all of that together. And lastly is the aspect that also Oleg talked about, that you need some form, for at scale, you need some form of orchestration for eSIM management. So tying actually quite a lot to manufacturing procedures also. So this whole tie leads to at least the first level of CMP, connectivity management platform, should be expected from the device vendor side. Then the same as with carriers have a CMP, and we're sitting on top of them with our CMP. Similarly, if you have a large scale and you have a lot of different device vendors and so on, you might have a CMP that works on our APIs as well. So I think that, like, I don't know if Oleg or Jerry have any other comments here, but otherwise we are wrapping up here we're on the last slide.
No, we have like 5 minutes left. We probably should open for questions. So I guess if somebody has any. So Bobby, if you see some questions in the room.
Yeah, actually, we will not get to them all because there are quite a lot, and I'll allow you guys to follow up directly with the askers after the event. One I can answer is, this is being recorded. It will be shared along with the information, so no worries there for those of you who are so excited about it and want to go back and listen again. A couple of questions. I'm just going to start with one. So let's see. If I'm going to read it straight out. What services does Itron offer to streamline the contracting with Verizon and AT&T data plans and eSIM profile provisioning, deprovisioning them when not in, deprovisioning them when not in use, and providing dedicated MZ ranges. It's a long question.
Yeah, maybe I can take this one. So it is important to look at the existing relation with the carriers. So when for instance, like many utilities, they have existing relation, but also at the same time, Itron, we do have relation with these carriers. So it will be an important distinction who owns the contract with the carrier. So if we own the contract with the carrier, so we will take care of acquiring the connectivity, of like provisioning all of this and so on. So if utility owns the contract with the carrier, then it's a little bit more complicated. So utility will need to work with the carrier on obtaining the profiles and providing this profile to Itron. So we in our factory or through our systems, we would manage this profile there. So, and then to answer the question more clearly, like what we offer. So we have all this tool chain to manage the technical capabilities on the profile, on the eSIM management. And then, so it is, we can help with like facilitating like either connectivity or on the contract, so we can participate in bringing in our expertise, what needs to be done or captured in the contract to ensure that this functionality can be provided.
And I guess, Oleg, we can say that, you know, one can leverage some of our large scale contracts also then to piggyback in on those for a new private utility deployment then.
Yeah.
Yeah.
I'm going to ask one more because I think we have time for one more. This one seems fairly straightforward. Maybe where does the EIM reside? Would the second part of the question is, would this need to be a hosted solution to support multiple carrier private LTE utility profiles?
Yeah, I can take that one, Bobby.
Okay.
So the EIM that Keegan hosts right now is in our GSMA SaaS accredited data center. We put it there because number one, it's a nice place because we have management solutions already built into that data center. But also number two, given how new the solution is, we wanted to basically give assurances to them and knows that the EIM itself is being treated securely and properly. But that being said, the EIM does not need to be in a GSMA accredited data center, right? And if there is a need for a customer to host a on-prem EIM, that is possible to do as well. But for now, the solution that we provide is a hosted one.
And I would add to that, Jerry, like we have a lot of discussion, like maybe moving that to, for at least for hosted customers, like to Itron's data centers as well. Exactly. That's another option.
For potentially deploying EIM on-prem for Itron. Exactly.
Yeah. Okay. We won't get to the rest. This is a huge group of questions, very technical questions. And I apologize to everyone who did take the time to type in a question that we won't get to. Some really great questions, though, that Jerry and Oleg and Jan will follow up on directly. And we will move forward with the conversation at the UBBA Summit and PlugFest in November. So I know this will be a great topic there. I'm going to stop there because we are just about out of time and say, first of all, thank you to Itron for setting this up, to Jan and Oleg for sharing your expertise, Jerry for coming alongside and offering those insights from Keegan. We so appreciate you all as UBBA members, and I appreciate you carrying the conversation forward in November. So for those of you on the call, go to ubbaplugfest.org and register to come to Charlotte and continue this conversation, meet with these guys face to face, ask the questions. But for now, I'm going to say thank you so much to everyone for being on today and for you guys for sharing your insights on this great technical and really critical topic for utilities. Thank you. Everyone have a great rest of your day. Be safe.
Thank you.